In today's class, we're going to discuss about cell coverage for signal traffic. I already briefed about this topic. But coming to signal coverage or traffic coverage, signal coverage is nothing but it has to cover the 100% geographical area of a cell. It has to cover the 100% geographical area of a cell, right? Which is an ideal case. Or also coming to traffic coverage. Traffic coverage is nothing but particular fixed number of cells are assigned, channels are assigned to particular cells. What the minimum number of channels have which are assigned to each cell should be covered the all the heavy traffic, right, without requirement of the additional channels, without the requirement of additional channels, right? To achieve this, to cover the signal coverage or traffic coverage, the geographical area of the cell, the geographical area of the cell must play an important role here. The geographical area of the cell must play an important role. That means generally if area are considered as a circular or hexagonal, right? But practically, which is not the case. The areas are of irregular shapes, right? In some of them are hilly areas, or some of the water or rivers are there. But in spite of this, the signal has to cover 100% area, but also you have to predict how much area will be covered by the signals. Right? Generally, the areas, the service areas are of the different environments, like human-made or natural terrain. Like the human-made structures, there are open areas. Urban areas or semi-urban areas. Whereas coming to natural terrains are hilly terrains, or some of them are flat, some of them over water, right? There may be inequalities in areas. There may be inequalities in areas. The prediction models are mostly useful to predict the signal coverage. Like the task of these prediction models are to cover the whole area with a minimum number of cell sites. That means the total area will be covered by using minimum number of cell sites. By using minimum of cell sites means we have to use a minimum number of antennas, and also at the same time minimum number of channels are sufficient for it. Right? The cell coverage is predicted by the prediction models. The prediction models are different for area to area and also to point, right? Definitely the service area will be one of the following human made structures, and or there may be natural terrains. It should be anyone from these two categories. One from these two categories, right? And also the results which are from the prediction models will differ based on the service area used. Will differ based on the service area used, right? It is the basic introduction about cell coverage or traffic coverage, signal coverage or traffic coverage. This is an example sketch. This is an example sketch in a flat terrain. That means if the area is flat, how to calculate different angles and how to predict the coverage. How to predict the coverage based on the prediction models, right? If we take this, there are two angles. One is the incident angle, other one is elevation angle. Incident angle is nothing but the ground incident angle and also ground elevation angle. Ground elevation angle is a pi, represented by pi, where the ground incident angle is represented by theta. Whereas the ground incident angle theta is the angle of wave arrival instantly pointing to the ground. That means the angle which is pointing to the ground is the ground instant angle, which is and also the ground elevation angle. The ground elevation angle is nothing but pi, is the angle of wave arrival at the mobile unit. One is at the mobile unit, other one is at the base station. Right? These are two angles: ground instant angle and ground elevation angle, which are used at the prediction of cell area coverage and also the signal coverage. Right? Another one is ground reflection angle and reflection point. Generally, the reflection angle and the incident angles are same. Here is the ground reflection angle and the reflection point. an example, it was discussed in last class. Now coming to Lee model, which is the point-to-point model. There are two prediction models, point-to-point or area-to-area prediction model. Here we are discussing in this topic is point-to-point model, and also called as the Lee model. The point-to-point model is obtained in three steps. Is obtained in three steps. One is generating a standard condition. Second one is obtain an area-to-area prediction model. And third one is obtain a point-to-point model. Obtain a point-to-point model using the area-to-area prediction model, right? That means the point-to-point prediction model will be obtained by using the area-to-area model. For that, we have to derive a general condition or standard condition here. To generate a standard condition, we have to use certain factors, correction factors. The advantage of using the standard values is to obtain directly a predicted value. Directly, the predicted values are obtained directly. Here at the standard condition, right? Here is the standard condition here. They both are at the base station at the mobile unit, right? Standard condition at the base station and also at the mobile unit. You are familiar that there are antennas at the base station and also at mobile unit. The antenna at the base station is high power antenna compared to the antenna at the mobile unit, right? And also the transmitted power. Also the transmitted power, which is 40 dBm, 40 decibels, right? You see the standard condition and also the correction factors also mentioned here. Correction factors are also mentioned here. The correction factors are at 10 log given dash by 10, which is derived as alpha 1. It denoted as alpha 1 and also at alpha 2. Also the alpha 3 is equal to G1 dash minus 6. G1 dash minus 6 and also the alpha 4 and alpha 4. There are different formulas for different correction factors. Right? And second one is obtain area to area prediction model. Coming to area prediction curves, these area to area prediction curves are different at different areas. In this, all the areas are considered as flat areas, even though there are non-flat areas. in area to area production curves, all the curves are considered, the areas are considered as flat areas, even though there are maybe non-flat areas also. The reason behind this is the area to area production model is an average process. Which is an average process. For that, all are considered as flat areas. The average value or the standard deviation of the average value indicates the degree of the terrain roughness. That means how much flat area will be, the degree of flatness will be indicated by the average values by using this area to area production curves, right? Next one is the effect of human made structures. The effect of human made structures. Even though the terrain configuration of each seat is different, and also the human made structure of each seat is also different, right? The natural terrain configuration also the same to human structures of each city will be different, right? You have to separate these two. We have to separate these two areas. For that, we have to derive a pathless curve. We have to derive a pathless curve. This means the different pathless curves obtained in each city shows the different human made structures in that city. For that, we have to measure the signal strength at those high spots and low spots surrounding by the cell sites. That means here the signal strengths of high spots and low spots will be indicated here. The high spots are indicated by H and the low spots by low. These are surrounded by the cell sites. Right? Here are different areas where which is L. L means there is a low spot. They are surrounded by the cell set. Or there is a H. That means high spot. They are surrounded by the cell set. And there is a distance between 5 miles from the. There is 5 miles. This is up to 10 miles distance from the basic cell sets. These are of propagation path loss curves for human made structures. These are used for measurement areas for high spot and low spot areas are measured. Right? Here is the path loss phenomena. The average path loss slope is calculated by using averaging the high spots and low spots. Right? Here is the distance indicated in miles from 1, 5, and 10. That means the diagram here will be represented in this way. Picture of different distances from the cell sites. Therefore, the differences in area to area production curves are due to different man-made structures. Due to different man-made structures, the measurements made in urban areas are different from those measurements in suburban and open areas. Right? Because the areas are different, then the production curves are also different. They may be natural terrains or there may be human-made structures. Right? The area to area prediction curve can be used for achieving the point to point prediction model, right? Which is the third step. First one is standard condition. Second one is point to point. Area to area prediction model. Third one is point to point prediction model by using area to area prediction model, right? In area to area prediction models, there are different areas, and further the prediction curves are also different, whether in man-made, human-made structures or natural terrains also. Right? Here the different areas, propagation path loss in different cities here. Propagation path loss is nothing but where the signal is propagated from a cell antenna to mobile unit. In the traveling, the path loss due to the disturbance in environment, the signal may lose some power, right? Further, there are different areas, free space, something in open area, suburban area, right? There are different measurements are given for different cities. This is a propagation path loss. These all are useful to predict the coverage area of cell traffic coverage or signal coverage. If the human structures are different from the cities are based on different. Set up a transmitting antenna at the center of the general area. This is a simple measurement. That means a transmitting antenna is to set up at the center of the general area. The antenna location is not critical as long as the building height is comparable to the others in the area. Like this, if you take 6 or 7 measured data points around the 1 kilometer intercept, 1 MI is nothing but 1 kilometer around based on the high and low spots. Based on the high and low spots, the data collected from the data points should be do average. Further, we will predict the coverage area of this particular areas. Right? If the area is a hilly area, and the data points are different, in this case, we have to take the data points obtain the average path loss slope. Otherwise, if the terrain is a hilly area, then the data points will be measured to convert the slope terrain to flat terrain in that area. Right? The conversion for that conversion is based on the antenna height gain as delta Z is equal to 20 log HE by H1. 20 log HE by H1. This is of antenna gain. Here is the path loss curves. There are different slopes based on 1 kilometer different 1 kilometer intercepts here. Right? There are different path astronomy of different areas. Here is the antenna. There are some buildings are here, which indicates the coverage area here. It will indicate it here by signal strength A, B, and C. A is at 1 mile intercept. That means nothing but 1 kilometer intercept here. And also here that is ABC. There may be a different distance from different areas here. Based on a direct path and a ground operated path, the line of sight, the received power is equal to P naught of some formula is here to calculate the received power. Where a suffix V is the reflection coefficient and also the psi. So the phase difference between a direct path and a reflected path. The P naught is nothing but the transmitted power, and D is the distance, and lambda is wavelength. This is the received power.